Welcome to this video on the sliding and the V, which may well be terms that you have never heard before, but these might be processes you're quite familiar with. So we're just going to run through them and make sure everyone's on the same page. So say I've got a fraction a bit like the one I've written here, 3x plus 7 over 2x. Now, you might not know it yet, but there's plenty of things I can do with this fraction. I can find out all sorts of things about the function it describes, but it's not particularly useful to me in the form that it's in. What I want to be doing is getting it into the form alpha x to the n plus beta x to the n, which just means this one's a number here, so is beta, and then m and n are powers. So I just want to get it into a number x to a power and then another number x to the power. And the way I'm going to do this is I'm going to use two techniques called, one called sliding and one called the V. Like I said, these aren't standard terms, but it's just a helpful way of thinking through the problem. So sliding. The idea here is that we're going to separate the numbers and the algebra from each other without changing the fraction and what it means and what it says. So what I'm going to do is I'm going to have a look at what I've got just in terms of the numbers here, and then I'm also going to have a look at what I've got in terms of algebra. So I'm going to put numbers in here, and then I'm going to put algebra in here. So in terms of numbers, on the numerator I have a 3, on the denominator I have a 2, and then in terms of algebra I have an x on the numerator and a square root of x on the denominator. Now, because I haven't, I've got this fractions multiplied, actually the way I've written it is perfectly legitimate, because I could still multiply across the tops of the denominators here and get 3x, which is exactly what I was hoping for, and I can multiply across the denominators there, 2 times root x is still 2 root x. So I haven't changed the fraction there, but what I've done is written it out a lot more helpfully for me. And now we can use what we know about our index rules to sort of simplify this down. So x is technically x to the 1, and we could write the square root of x as x to the power of a half. Now, our index rules tell us that if we're dividing x to the power of 1 divided by x to the power of a half, that we would subtract our indices, our powers. So that would give me x to the power of 1 take away a half. Now that might be completely obvious to you, but it's worth remembering and just recapping. So that would give me x to a half overall. So now what I've been able to do is write that as a term, some number x to some power. And that's brilliant, because that allows me to differentiate and integrate, which are techniques we're going to come on to later on in your course. The V is just a helpful way of remembering which way up this next technique goes. So here in this fraction, I've got two things. I could have more, added or subtracted together on the top of a fraction, and a single denominator. Now, if I circle these two values here, the 3 and the 4, and then also circle the 4 and the 5, I sort of get a V shape going on here. Now that is brilliantly helpful to me. That means what I can write is 3/4 add 5 over 4, and you might recognise the process in this direction, so going from what I've just written back to the question. If I was adding two fractions, we know we'd make the same denominator. We'd give both fractions a denominator of, say, 4, in order to go to the bit in the kind of ochre colour here, the 3 plus 5 over 4. So you recognise it in this right to left direction. We're now trying to get you to recognise it in this left to right direction here. And it's nice to do it with numbers. Obviously we will do algebra in a minute. But here we know that 3 plus 5 is 8 divided by 4, and that is definitely 2. And I can do the same thing on the other side of this equation as well. So 3/4 add 5/4 is still indeed 8/4, and that is still 8? Let's try that again, shall we? That would be 8 divided by 4, which is 2. It's quite late at night. So let's try it with a bit of algebra. So say I have, let's even do some mixed terms here, x plus y divided by x. Why not? Using the v then, I'm going to consider this as a fraction and also this, giving myself this kind of V shape and helping me obey the rules of mathematics here. So that gives me x divided by x and then y divided by x. And of course I can simplify that first fraction. Anything divided by itself is just 1. So I end up with 1 plus y over x. Now there is a warning here. Warning. It does not work upside down. So I think, you know, sometimes we get to this point where we're like, oh, wait, hang on, I can see this sort of V shape. It's not the right way around, but that's okay, because I recognise this. I always think this is R. Is that how you spell R? Maybe there's an R in there. No. Doesn't work. We can see that. 4 over 3 plus 5 is 8, which is a half. Now, if we apply the V, hence the name, the V, this way, I'd end up with 4/3 add 4/5, which, well, I don't really want to work it out, but I definitely know it's greater than 1. It's certainly not a half. So going this upside down way just does not work. This is an no. This A shape is a no-go for us. We definitely want to stick with it as a V shape. So let's go back to our original problem and pull these two ideas together. So at the moment I can't really do any sliding because not everything is multiplied. I've got this addition across the top here. So I helpfully have another technique for that, and I'm going to use it right now when I can change the colour of my pen. Oh, that will do. Something a bit different. I'm going to use the V first. So there's one fraction I'm going to consider, and there's the other one. So that gives me 3x over 2x and 7 over 2x. Great. Now I can slide. So in my first fraction, the numbers I have, well, on the numerator I have 3, on the denominator I have a 2, and then the algebra I've got an x and then an x on the denominator as well. And we're going to do the same for this second fraction. So the numbers I have a 7 on the numerator and a 2 on the denominator. Now here's a little bit of an interesting case. I have no algebra on my at the top of my fraction, on my numerator. I don't want to replace this with a 0 here because 7 times 0 is 0 and I don't want nothing. So I'm going to have to call this 1 because 7 times 1 is 7, so that will work for me. And the x on the bottom. And now hopefully you can begin to see how useful this technique is. I bet you anything I would have ended up with a load of 7 over 2 x's if I'd given this to you as a question but without teaching techniques to you. This x has a tendency to kind of bubble up, but here we can quite clearly see that it's on the bottom of this fraction. Okay, so sorting it out into the form that I want it in, don't forget, which is alpha x to the m plus beta x to the n. This gives me 3 over 2, there's my number, there's my alpha. Technically x to the power of 0, so we might not want to write that, but we'll write it for a minute. And then 7 over 2, x to the minus 1. Don't forget 1 over gives you a minus 1. And we could, of course, rewrite that as 3 over 2 plus 7 over 2, x to the minus 1. Hopefully that's helped you answer the questions in your Starting with Confidence booklet and begin to understand how important it is to be really accurate with your algebra at A level.